Okay, let's back to where we stopped before the break. Okay, we say simple random sample assumption is more important than the normality assumption. When x1 up to xn is not a simple random sample, then sample mean subtract by population mean over sample standard deviation divided by square root n don't follow t at all. But when normality assumption is violated, for some cases, we can still use T procedure. Okay, now we're going to explain this. Okay, we're going to explain this. In what cases? Let me give you an example. Okay. Now, for example, let me try one more time. Example. For the violation of normality assumption, this example show you when the normality assumption is violated. For some cases, we can still carry what? A T procedure. Suppose I give you a box. In the box, there are tickets. You have one number one ticket, two number two tickets, three number three tickets, two number four tickets, and one number five tickets. So the population size is 9. One, two, three, four, five, six, seven, eight, nine. 9 tickets. Okay, and we make 3 draws randomly. We randomly select 3 tickets from the box with replacement. Okay, this is with replacement. Since it's with replacement, as we discussed earlier in central limit theorem, when I make the draw from the box with replacement, the draw are independent. And the draw is also what? The draw is also identical. So the draw are independent and identical. Okay, so we can claim x1, x2, x3 is a sequence of ID random variables. So that means it's a simple random sample. Okay, so we do have the simple random sample. We do have a simple random sample assumption here, but the normality assumption is what? Is violated. Okay? Why normality assumption is violated? Let's draw a graph from the box. This is a population distribution. This is 1, this is 2, this is 3, this is 4, this is 5. How many number 1 ticket? We have only 1. How many number 2 ticket? We have 2. How many number 3 ticket? We have 3. We have 2 number 4 tickets. We have 1 number 5 tickets. Okay, so let's see. What is the shape? It's the shape is what? Triangle. And what do you know about normal distribution? Normal distribution is bell-shaped. So for sure, this is not normal population. Is that okay? Because you can see it's not bell-shaped. Can you see that? It's triangle shape. So normality assumption is violated. Although normality assumption is violated, but let's look at the main feature of this triangle shape. First one, although this is not what? Bell shape, but it has all the main feature that bell shape what? Has. First one, this is unimodel, one peak. And second one, you find this is what? Symmetric. And the third one, you find in this picture, you don't see what? You don't see outliers. No outliers. So even though this is not bell shape, but this shape has all the important features that a normal distribution has. Okay, so we can still we can still use T procedure. And that means you take out the sample, right? X bar minus what? Mu divided by sample standard deviation over square root n. This one still what? Follow approximately P with what? 2 degrees of freedom. Is that okay? So even this picture shows the population distribution is not normal, but we can still get what? We can still use T procedure. That is sample mean subtract by population mean over sample standard deviation divided by what? Divided by sample size. This is still follow approximately P with 2 degrees of freedom. Okay? This is what we mean. Normality is what? Normality is not, normality assumption is not as important as what? As simple random sample assumption. Okay? Now, let's move on to the next page. Okay? Next one, we're going to show you how to use T-table. Okay? Next one. Next one. The use of T-table. Okay? The use of T-table. Look at here. Does the expectation of good weather lead to more generous behavior? Psychologists study the size of the tip in the restaurant when a message indicating that the next day's weather would be good was written on the bill. Here are the tips from 20 patrons, measured in what? Percent of the total bill. Okay? So in this example, what is available of interest? The available interest is X. And what's X? Let X be what? The tips. Measure in percent of the total bill. Okay, so look at the given data set. This is X1, this is X2, this is X3, this is X4, and this is X10, this is X11, X12, all the way up to X20. So what is the assumption we made? We assume X1, X2 up to X20 is a simple random sample from what? From normal population. With mean mu x and sigma x squared. Both mu x and sigma x are unknown. Okay? And what we want to do, we want to estimate the mean percentage tips. Okay? Mean percentage tips in our notation here is mu x. Remember, we say mu x and sigma x squared. In the real life application, both are unknown. Okay? Both are known. And we want to estimate the mean percentage mu p for all patrons of this restaurant when they receive a message on their bill indicating that the next weather will be good by given what? 95% confidence interval. In other words, we want to find a 95% confidence interval for what? For mu x. As I mentioned earlier, when people give us a data set, okay, to check whether the normality assumption is violated or not, we better what? We better give a simple plot for the given data set. You can use histogram or use computer software. Here I'm just use what? A stem plot. Very quickly, draw the graph, okay? I draw the graph like this. Okay. The first one, the smallest one is what? Let's see. The smallest one is 18.7. Am I correct? So this one begins with 18.7, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. What's the largest one? The largest one is in 27.0. So let's finish what? The stem plot, okay? First one, 20.8, 20.8. And next one, 18.7. And then 19.9. And next one, 20.6. And next one, 21.9. Next one, 23.4. And next one, 22.8. Next one, 24.9. 22.2. 20.3. Next one, 24.9. Next one, 22.3. Next one, 27.0. Next one, 20.4. Next one, 22.2. Next one, 24.0. Next one, 21.1. Next one, 22.1. Next one, 22.0. Next one, 22.7. So if you look at what? The picture very quickly. You find what? What can you say about the graph? Huh? We say roughly what? symmetric. And what? And you find unimodel. And also what you find? You find there's an outlier. Conclude from all three, we see from what? The stem plot. We not consider this is what? This is not considered as a serious violation to the normality assumption. This is not considered as a serious one, violation to the normality assumption. So we still go ahead to use T procedure, okay? So we want to build 95% confidence interval for mu x. Remember what's a formula? Well, we always begin with what? Estimate. Plus or minus h. H is what? The margin of error. Okay? And what is the observed value of our estimator? Well, x bar is in the question we give you already. X bar is 22.21. So this is x bar plus or minus, what's h? Marginal error. Z star, the critical z value, times what? Square root of variance of our estimator, x bar. Okay? Okay, so this is x bar, the observed value of estimator. I use lowercase as x bar. Okay, plus or minus z star times variance of x bar is sigma square over n. So if I further simplify this, this is x bar plus or minus z star times sigma over square root n. But remember, in the real life application, we don't know sigma. Sigma is unknown. So it is replaced by S. After replaced by S, when we don't know population standard deviation, we estimate by sample standard deviation. The resulting statistic is no longer Z, it becomes what? It becomes T, student T distribution, okay? It becomes student T distribution. So let's plug in the numbers, okay? The observed value of x bar given here is 22.21 plus or minus critical T value. This one requires T table. And S is given 1.963 divided by square root n. Sample size is 20. So our job left undone because we need to find what? T star, okay? The critical T value. But how can we find critical T value? The critical T value. Or some people call this is table T value, okay? Or some people call this is table T value. And how can we find this T value, okay? Now let's look at our textbook. This is T with what? 20 minus 1, which is 19 degree of freedom. Sample size minus 1. And this is our T distribution, bell shape, okay? And center of the bell shape is what? Is 0. This is 0, okay? And we want to build 95% confidence interval. That means The upper tail is 2.5%. And the lower tail is what? Also 2.5%. Okay? Now, let's see, how can we use table to find out the critical T value? Okay? If you have the book, you can open your book at the same time. Okay? This is a T table in our book. What's the degree of freedom? What's the degree of freedom? We see what? Is 19, but we don't see 19, right? So in this case, this is 18, this is 20. If we don't see 19, well, we just move to the largest one that is smaller than what? 19. Okay, look at here. And we stop right here. Okay, we start right here. This number is what? This number is, let's see, 2.101. Okay, why I stop here? Because you move down. The right tail probability to that is what? 2.5%. So if I use the textbook, the table is 2.101. Okay. This is actually from what? T with 18 degree of freedom. If this is 19, you don't use what? You don't use 20. You use what? 18. Okay. Use the largest degree of freedom, not exceeding what? Not exceeding 19. Okay. This is more conservative. This is more conservative way to do it. Okay. Now, 2.101. But if you do have the table come with 19 degree of freedom, then you will find the critical T value is what? 2.093, which is very close to the one I just showed you, 2.101. Okay. So after you plug it in, the number, what do you get? You get the 95% confidence interval. For what? For mu x is from 21.29% to 23.13%. Usually, if people go to the restaurant, they pay about 15%. So this is considered very high what? Percentage for tips. So we can conclude that, yes, when what? When they receive a message on their bill indicating the next day's weather will be good, then the waiter or waitress tend to get what? Higher tips. That's our conclusion. Okay. Now, before I close the topic, let's look at the T distribution table again. Okay. Let's look at this again. So I can give you more detailed explanation of using what? T table in your textbook, since this will be the table you use for your final exam. Okay. Now let's see. Look at here. Say I want to build for other case. Say I want to build Say I want to construct. A 95% confidence interval for a non-unknown population mean mu. Okay? What is the corresponding t-value? If 1, degree of freedom is what? Degree of freedom is, say, 3. Okay? Degree of freedom is 3. So let's look at the table here, the textbook. Degree of freedom is 3. I move my finger towards what? The right. And I stop here. 2.312. I move up. I find the right tail probability is what? 0.025. And left tail probability is 0.975. What does that mean? Okay, 3 degree of freedom is 3.182. Okay, look at the picture here. This is t with nu equal to 3 degree of freedom. And the center of the t curve is 0. And I just show you that number is what? That number is 3.182. The corresponding upper tail, this is 2.5%. That means the other what? The other side. This one will be 97.1. 97.5%. So 3.182, the corresponding right tail 2.5%, the corresponding left tail 97.5%. Okay, and this is t with what? 3 degree of freedom. Let's check the table again. When degree of freedom is 3, okay, you find 3.182. You move your finger up to here. This is 2.5%. This is right tail probability. And corresponding left tail probability is 0.975. Okay? And that is the picture I just showed you. Okay? 2.5% plus 97.5%. They add up to what? 100%. Okay? They add up to 100%. Let's try one more example. Okay? Let's try one more example. Suppose I want to what? Suppose I want to construct a 99% confidence interval for mu. Okay? So what is the critical t? What is the critical t value or table t value? What is the critical t value? If degree of freedom is what? Degree of freedom is 10. Okay? So in this case, let's draw the picture. Okay? Let's draw the picture. This is t distribution with 10 degree of freedom. Okay? And center here is still 0. Okay? And how are we going to use the table? Look at here. Degree of freedom is 10. So you move your finger horizontally. Okay, you keep moving, you keep moving, you keep moving until you see what? Until you see 3.1169. Why you stop here? Because you move up, you find the corresponding right tail is what? The corresponding right tail is 5%. And the corresponding left tail is what? 99.5%. Okay, that is to say, this number, 3.169. This number, 3.169, the corresponding upper tail is 0.005, and the corresponding left tail will be what? Will be 0.995. But T distribution, just not like normal distribution, is symmetric, right? So this is minus 3.169. This lower tail is also what? Is also 0.005. So the middle area, this middle area is what? Is 99%. Okay? So that means from minus 3.169 to what? 3.169. This area cover what? Cover 99%. So when you want to construct 99% confidence interval, in the table, you should check the upper right tail is corresponding to 0.005. Because symmetric, the lower corresponding tail is also 0.005. So between 3.169 to minus 3.169, cover the middle one, 99%. Okay? Okay, that's all for how to use T-table. Okay? Okay, let's stop here for today's class.